Hi, welcome to the 1.3 Notes, Nuclear Notation and Representation of Atoms video. So at the top of your note page, you want to make sure you have your section number, 1.3, your title, and then your page number. If you need more time, you can pause the video. I also want to remind you to make sure that you have in your table of contents you included your section number, the title, and what page it starts on in your notes. So don't forget to go back and do that in your table of contents. All right, let's go back to our notes. So first thing we're going to do in the notes is define what representations of atoms are. We've already been learning about atoms, the subatomic particles of atoms, and how atoms are structured. And now we're going to go into different ways of representing atoms. So representations of atoms are depictions of atoms that provide information about the atom's characteristics or properties. So that would include the atomic number, which tells you the element's identity, the mass number, and the charge. So again, if at any time you need more time to copy the notes, just pause. There are different ways to represent an atom, like using a Bohr model. And I wrote see page 9 in this notebook. So remember, in the notebook for your notes, section 1.1, you drew a Bohr model. So my Bohr model is on page 9, so I wrote see page 9 in the notebook. So you would write whatever page your Bohr model is on. So I'll start again. There are different ways to represent an atom, like using Bohr models, see page 9 in this notebook, but those are harder to draw, especially for large atoms. It's easier to use nuclear notation instead. So Bohr models tell you a lot of information about the protons, neutrons, and electrons, and therefore the characteristics and properties, but when you have really large atoms that have a lot of protons, neutrons, and electrons, those are difficult to draw. So we're going to see an easier way to represent an atom. That's called nuclear notation. If you need more time to copy these notes down, please pause the video. Okay, so now we're going to go into the structure of nuclear notation. It has a specific structure. So in the center, you have your what's called your element symbol, and that's represented by this big X. So when I say an element symbol, that's what we get from the periodic table. These are element symbols, like Na is the element symbol for sodium, Cr is the element symbol for chromium, etc. Now, one thing that's important to know for element symbols, you notice that all of the element symbols start with a capital letter. And then the second letter will be lowercase, and so with the third letter. So basically in an element symbol, the first letter is capitalized and the rest will be lowercase. And they do that so that when you have a molecule that has more than one atom, or a compound that has more than one type of atom, you know that the atoms are separated by capital letters. So just keep that in mind. So in the middle of your nuclear notation, you have your element symbol, which you get from the periodic table. In the upper left, you'll have your mass number. Now remember, the mass number from our last section 1.2 is the number of protons plus neutrons. So remember, to get the mass number, you just add the protons to the neutrons. And that makes sense because a proton and a neutron, they each have a mass number of approximately 1 AMU, and they contribute the most to the mass of the atoms. The electrons contribute very little. The second symbol, or second part of the symbol we're going to look at, is the atomic number. Now the atomic number, which is the number of protons, is in the lower left and is represented by this symbol Z. And remember, the atomic number is what you use to identify the element from the periodic table. So if you have the atomic number, let's say the atomic number is 5, then you can figure out which symbol it is by looking on the periodic table and finding which element has number 5, and that's boron. So in the middle where the X is would be a capital B. Okay, so we went over the structure so far, going over this element symbol, atomic number, and then the mass number. Now the last thing is in the upper right-hand corner is where you would put the charge. The charge, remember, is basically the balance of protons and electrons, right? So you can either calculate the charge by doing protons minus electrons, or you can use mental math. And so, for example, if you have 2 more protons than electrons, you know the charge would be positive 2. if you have 3 more electrons than protons, you know the charge will be -3. So all of that information we covered in the last unit, or the last section of the unit. So 1.2, and this table here sort of gives you that information. We also looked at some examples. So if you need to, you can sort of go back to 1.2 to make sense of it. All right, so this is the structure of the nuclear notation. So when we write a nuclear notation, we have our element symbol in the middle. Upper right is the charge, upper left is the mass number, and then the lower left is the atomic number. So now what you're going to do is you're going to watch a video where Tyler goes over some examples of writing the elements, the nuclear notation, and also examples where he uses the nuclear notation to determine protons, neutrons, and electrons. And you're going to write these, you're going to follow the examples in your notebook. So I sort of set up how I would set them up. So for the first example that you'll see, you need to determine the number of protons, number of neutrons, number of electrons in this symbol. So he gives you this symbol. Notice how the mass number is in the upper left, atomic number is in the lower left, and the charge is in the upper right, and the symbol's in the middle. So you're going to use this information to determine protons, neutrons, and electrons in this atom. All right, I'm going to show you the last 2 examples, but if you need more time to copy this information, you go ahead and pause the video now. Okay, the last few examples that you're going to look at, which sort of showed you the nuclear notation. You're determining the number of protons, neutrons, and electrons in this nuclear symbol. So again, this is what the setup looks like. And then finally, for the last example, you're going to write the nuclear notation of a symbol for an element with 15 protons, 17 neutrons, and 18 electrons. So here in this space, you're going to figure out the element symbol, the atomic number, mass number, and charge, and write them in a way, in the correct format or structure. All right, that is it for this video. And next time we're in class, we're going to do more practice with this. Have a quality day.